Planet 9 is one of the greatest modern mysteries in astronomy, a ghost in the darkness that may or may not exist, a massive body that could be drifting in the furthest reaches of our solar system. For decades, scientists have debated whether there is a hidden planet lurking far beyond Neptune and Pluto, a place where sunlight is nothing more than a faint memory and temperatures plunge to unimaginable lows. The idea of Planet 9 challenges our understanding of how the solar system formed, what objects inhabit its outskirts, and how little we actually know about our own cosmic neighborhood. Many people assume that because we've mapped the planets and explored space probes, we must already have a complete picture of everything orbiting our sun. But the truth is the opposite. The more we discover, the more questions we uncover. The outer solar system remains a frontier of shadows, uncertainty, and open mysteries, and Planet 9 is perhaps the most compelling among them. The story of Planet 9 does not begin in the modern era with advanced telescopes and computer simulations. It starts centuries earlier, with the discovery of Uranus in 1781 by William Herschel. Herschel did not set out to find a new planet. He was scanning the sky in search of comets using a homemade telescope. When he spotted a faint object moving slowly against the backdrop of stars, he assumed that it must be a comet because comets were the only known bodies that moved like that. But as he continued to observe the object and noted its path, he realized that something was unusual. The object was not behaving like a comet should. It was too slow, too stable, and over time astronomers realized that Herschel had discovered a new planet. At the time, it was incredible to think that something so large could go unnoticed by humanity for so long. But Uranus was faint, slow-moving, and just at the limit of naked-eye visibility. It blended into the night sky, hiding in plain sight for millennia. The discovery of Uranus changed everything. It proved that the solar system was not a closed book. There could be more planets beyond those known to ancient civilizations, and they might be waiting to be found. As astronomers continued to track Uranus's orbit, they noticed something odd. The planet was not moving exactly as expected. It would speed up slightly and then slow down, as though some unseen mass was tugging on it. This strange motion could not be explained, using only the gravitational influence of the known planets. The idea began to form that perhaps another planet existed further out, influencing Uranus's orbit. Two mathematicians, John Couch Adams in England and Urbain Le Verrier in France, made detailed calculations of where such a planet must be located in order to cause the observed perturbations. They did not need to see the planet to know it was there. They used mathematics and physics to predict its location. Then, in 1846, the astronomer Johann Galle pointed a telescope at the predicted position and found Neptune almost immediately. The discovery of Neptune was a monumental achievement. It was the first planet discovered not by accident, but by mathematical prediction, using the laws of gravity. It demonstrated that invisible forces could reveal hidden worlds. The success of Neptune's discovery inspired astronomers to continue searching for more planets. When they looked closely at Neptune's orbit, they believed they saw strange behavior there as well. They assumed that perhaps another planet lay even further out, tugging gravitationally on Neptune in the same way Neptune had tugged on Uranus. This hypothetical planet became known as Planet 10th. Then came Clyde Tombaugh in 1930, a young astronomer who discovered Pluto. Pluto was identified through painstaking work, photographing the night sky and comparing images to spot any small moving object. It appeared bright and large because of its reflective icy surface, and so many astronomers assumed that they had found Planet 10th, but this assumption was based more on hope than truth. Pluto was far too small to cause the perturbations in Neptune's orbit. It was only later discovered that those perturbations were measurement errors, not real gravitational influences. Yet the damage was done. Pluto was accepted as the 9th planet until 2006, when it was reclassified as a dwarf planet. But more importantly, the discovery of Pluto did not end the search. It only showed that finding planets in the outer solar system is incredibly difficult. The mistake did not disprove the idea that large bodies might exist beyond Neptune. It only highlighted the need for better tools and deeper exploration. Now fast forward to the modern era. With advanced telescopes and more detailed sky surveys, astronomers have begun locating countless objects far beyond Neptune in what is known as the Kuiper Belt. This region is home to icy bodies of all sizes, from tiny chunks of rock to dwarf planets like Pluto, Eris, Haumea, and Makemake. The Kuiper Belt contains thousands of Pluto-sized objects and countless smaller ones. It is a chaotic region filled with frozen debris, remnants from the early days of the solar system. These objects are so numerous that we have barely scratched the surface of this region. Their orbits, when mapped, show patterns that shouldn't exist if all objects were randomly distributed. In 2016, astronomers Mike Brown and Konstantin Bedijan of Caltech analyzed several distant Kuiper Belt objects and discovered something surprising. Many of them shared a similar alignment. Their orbits were all elongated in the same direction and tilted at similar angles. That should not happen by chance. If these objects formed randomly, their orbits would be scattered in all directions. Instead, they appeared to be shepherded by something massive, like dust swirling around an invisible broom. And the only explanation that fits the observed behavior is the presence of a large, unseen planet. By running simulations, Brown and Bedijan found that adding a large planet with a mass between 2 and 6 Earths, orbiting far from the Sun, could explain the observed clustering perfectly. Without Planet 9, the simulation did not match reality. With Planet 9, the outer solar system behaved exactly as we see it today. According to their analysis, the probability that the observed clustering is random is less than 0.4%. That means there is a very good chance something massive is out there. If Planet 9 exists, what might it look like? It would not be a gas giant like Jupiter or Saturn. It would be too small for that. Instead, it may resemble a super-Earth, a rocky and icy planet with a solid core, possibly wrapped in a thick layer of frozen gases. Its surface would be extremely cold, with temperatures near absolute zero. Sunlight would be no brighter than a faint star, and the planet would be shrouded in near-eternal night. Planet 9 may be the failed core of a gas giant that never fully formed, or it might be a planetary refugee from another star system, a rogue planet captured by the Sun's gravity billions of years ago. Capturing a rogue planet is not impossible. In the chaotic early years of the solar system, interactions between forming planets LD have flung bodies outward. Some were ejected entirely and drifted into interstellar space. Others may have been slowed or trapped by gravitational forces and remain in wide, distant orbits. Planet 9 could be one such captive. Yet, despite the confidence of some scientists, not everyone agrees. Skeptics argue that the observed clustering may be caused by observational bias. The Kuiper Belt is vast. We can only see objects that pass near the parts of the sky we can observe. It is possible that the pattern we see is an illusion caused by limited data. Some astronomers suggest that we need to find many more Kuiper Belt objects before drawing conclusions, and others propose even stranger explanations. One hypothesis suggests that gravity itself may behave differently at extreme distances from the Sun. Our understanding of gravity is based on Newtonian physics, which works extremely well for most purposes. But Newton had no idea that objects existed beyond Saturn, let alone thousands of astronomical units away. If gravity weakens differently than we expect over large distances, that could cause the observed clustering without the need for a Planet 9. Then there is the most wild speculation, the idea that instead of a planet, the unseen object could be a small primordial black hole. Primordial black holes are theoretical objects that may have formed shortly after the Big Bang, during the earliest moments of the universe. If such a black hole exists in the outer solar system, its gravitational pull could mimic that of a planet. Of course, there is no evidence for this, but neither has the idea been proven impossible. Ultimately, whether Planet 9 exists or not will be determined by observation, not speculation. The problem is that Planet 9 is incredibly difficult to detect. Even if it is several times the mass of Earth, it would reflect almost no sunlight. It would move very slowly across the sky. To see it, we need powerful telescopes and precise surveys. That is where the Vera Rubin Observatory comes in. With the largest digital camera ever built and the ability to scan the entire sky every 3 days, it will create a time-lapse map of the universe. If Planet 9 exists, its slow movement will eventually betray its presence. In the next decade, we may finally learn the truth. If Planet 9 is real, we will discover it. If it is not, our models of the outer solar system will need revision. Either outcome will advance science. Whether we find a super-Earth, a rogue planet, or nothing at all, we will learn more about the forces shaping our solar system. And perhaps most importantly, Planet 9 reminds us of our ignorance. It proves that even in our own backyard, mysteries remain. It shows that our map of the solar system is far from complete. We often assume that because we have satellites, telescopes, and space probes, we must already know everything worth knowing about the planets. But when you step back and consider the vastness of the solar system, it becomes clear how little we have explored. The region within the orbit of Neptune is tiny compared to the vast space beyond it. The Oort cloud, which may hold trillions of icy bodies, extends nearly a light-year from the Sun. In that context, our knowledge is like searching a beach for shells using a flashlight in the dark. We have only illuminated a small patch. Planet 9 is a symbol of that unknown. It may exist or it may not, but the search for it is a search for knowledge, driven by the belief that the universe still holds secrets. The debate surrounding its existence has reignited interest in the outer solar system and motivated new observations, new theories, and new explorations. Even if Planet 9 turns out to be a phantom, the scientific journey it inspired will leave lasting benefits. What makes the mystery especially compelling is that it is happening right now. This is not a solved problem from the history books. It is an unfolding story. Future astronomers may look back on this era as the time when humanity discovered the first super-Earth in our solar system, or the time when we finally learned the limits of our gravitational understanding. Either way, the hunt continues. Planet 9 teaches humility. It forces us to acknowledge how much we still have to learn. It encourages us to search, to question, and to remain curious. Whether a hidden world lies in the darkness or not, the question itself pushes the boundaries of science. In the end, the mystery of Planet 9 is more than a search for a planet. It is a search for answers in an unfinished cosmic map. A reminder that even after centuries of exploration, the universe still has surprises left for us.